So we're going to take 3x squared minus 4x plus 5 and divide it by x minus 2. So if we set things up like long division, this is what we're dividing, and we're dividing by an x minus 2. Now in long division, we always looked at the biggest numbers and tried to get rid of those, or get as close to them as possible. So if we look back at our example before, when we had 13 and 27/48, the biggest number that we looked at first was the 27, and the closest we could get to that was 26. Well, with algebra and polynomials, we will actually be able to get even closer. So first of all, what we're dividing, the 3x squared minus 4x plus 5, we're going to say this is in order and this one is the biggest one. Is there a way that I can multiply something by x minus 2 to get a 3x squared? Just a 3x. If I wanted to get a 3x squared, and I wanted to multiply something by this x minus 2, can you see that if I multiplied a 3x by that x minus 2, I would get a 3x squared? I would get other stuff as well, but I would get that 3x squared. So our first goal is looking at the biggest value and saying, what could I multiply this x minus 2 by to get that 3x squared? And since it's a 3x, in the same way that you wrote hundreds over your hundreds columns, tens over your tens columns in long division, we're going to rewrite the 3x over your x column. And then, just like before, you are going to multiply 3x times x minus 2. And you get 3x squared. And 3x times the minus 2 is minus 6x. I'm going to put this in brackets because we're going to subtract. And if I take what I originally had, which was 3x squared minus 4x plus 5, and I subtracted 3x squared minus 6x, well, this will be 0. And this is where you're going to have to be careful, because we have a negative 4x, subtract a negative 6x. It's going to be a plus 2x. And we have a 5, subtract, and there's nothing here. You could write a plus 0 if you wanted to, but most of the time you won't. But 5 minus nothing, you would still have a plus 5. And just like our long division from before, we now look at what's left, which is 2x plus 5. Look at the biggest value there, which is a 2x, and say, is there anything I could multiply x minus 2 by to get a 2x? It would be a 2. And so now you'd write that plus 2 above your 1's column, because you're just writing a constant. And 2 times x minus 2 would be 2x minus 4. Again, we're going to put it in brackets, and we're going to subtract. Well, this is going to be 0, and 5 minus a negative 4 is plus 9. There's your remainder. So 3x squared minus 4x plus 5 divided by x minus 2 leaves us with 3x plus 2, remainder 9. Doesn't divide perfectly, but we've used the same idea of looking at your biggest value, figuring out what you can multiply to get rid of that, then seeing what you have left, and doing the process over and over again. Yes? It's a fraction of, like, it's 9 over x minus 2. Yes. So let's look, just so we can see another one. Start to see if you can see the pattern. Let's do the second one. So we're dividing, we've got 2x cubed minus x squared minus 2x plus 1 divided by x plus 1. And again, we're going to look at the biggest value, which is 2x cubed, and say, is there something that I could multiply this x plus 1 by to get 2x cubed? And really, what you're looking for is you're really ignoring that second value. The plus 1 doesn't matter at the beginning, right? It's just like, if I need to get a 2x cubed, what do I need to multiply x by to get that? 2x squared. And so I'll write that above my x squared column, 2x squared, and then multiply that 2x squared by the x plus 1. So I'll get my 2x cubed, and 2x squared times the plus 1 is plus 2x squared. Put that in brackets and subtract. We put it in brackets so that we remind ourselves that we're subtracting all of that. Obviously, 2x cubed minus 2x cubed is 0. That's our goal, to get rid of the biggest one. And a negative x squared minus 2x squared gives us negative 3x squared. Negative 2x minus nothing is still negative 2x, and you still have the plus 1. And so now, there's our largest value. Well, what could I multiply an x plus 1 by to get a negative 3x squared? A negative 3x. And again, you take that negative 3x, you multiply it by the x plus 1, negative 3x squared minus 3x. Put that in brackets to subtract. Again, this goes away, which was our goal. A negative 2x minus a negative 3x gives us a plus x. The number one thing you're going to do in this when making mistakes is with your negatives, forgetting to subtract a negative and getting that all mixed up. So make sure you take some time to pay attention to that. And then, how do I get an x when I have an x? I'd have to multiply by just a plus 1. And again, everything lines up nicely with our columns, and when we multiply x times x plus 1, we get x plus 1. If we subtract that whole thing, we get no remainder. It's perfect, okay? And when it works out perfect, just like this, what does this mean? When we did 4212 divided by 27, got 156 perfectly, what we can tell ourselves is we can say that 4212 is equal to 27 times 156. That works out perfectly. When it didn't work out perfectly, okay, when we had our remainder of 5, what can we say about this first one? Well, this first one, 2748, it's equal to 13 times 211, and it didn't quite work out perfectly. There's still 5 more that were needed to make this work. That's what that first question was telling us. That the closest we could get is 13 times 211, but we'd still have a remainder of 5. Well, now, what can we say about this second one? This second one tells us that 2x cubed minus x squared minus 2x plus 1, that's equal to x plus 1 times 2x squared minus 3x plus 1. Oh my goodness. What did we just do? We just started to factor something we've never been able to factor before. Up till now, we've only been able to factor quadratic equations or things that had a common factor. But if we had something with a 2x cubed, we're like, no, I don't know how to factor that. And so one of the things that this long division is getting us towards is how to factor bigger polynomials. In fact, does this even factor even more? I think it might. Because now this is a quadratic. You know how to factor that. Does it work out? It does. So we could factor this expression completely. And so because we can do that, that's going to lead us into this chapter. At the end of this chapter, not only will you learn how to factor cubics, okay? And this one, we were given a hint and said, try x plus 1 first. It worked. But how do we find that one that works first? We're going to find that out, right? Because in the other one, we tried x minus 2. It didn't work. We're also going to learn how to graph cubics that are in this form, something that we couldn't graph from before. It's not our regular transformations. So we're going to use this factoring to help us graph cubics and quartics and quintics and different kinds of polynomial functions. All right, so this is the beginning. In your notes, they've got an example as well here. Wow, what are these numbers? Oh, cool. Let's click on them. Same thing. Again, you're looking at your biggest number, x squared. Color coding this is nice. In order to get that biggest number, what do I have to multiply x minus 1 by to get an x squared? That's how I get that x. I multiply that x times the whole thing of x minus 1, and I would get x squared minus x, and you subtract to find out what's left. And now your biggest value with what's left is a 3x. So you go through this process. It's an algorithm in such that you do the same process over and over again. If you can do the process right once, now we look at 3x plus 5 and say, what can I multiply x minus 1 by to get a 3x? Well, that would be 3. And 3 times 3x minus 1 would be 3x minus 3. We subtract again, and we get a remainder of 8. So we would say the quotient is the x plus 3. The remainder is 8. And pull out your highlighter because this is an important thing. We have to write our polynomial in descending order. And that never was a problem with long division before, right? Like if we go back to our first numbers, did anybody want to write 2,748 like this? 2,748. Yes. Yeah? That makes total sense to you? I like to write my thousands here, my hundreds here, my tens here, my ones there. If I do that for the rest of the semester, will you guys be okay if I just mix that up every once in a while? Right? You get your test back and you're like, Mr. JR, I'm so sad. I'm like, why? You got 91%. That's great. I'm sorry, I'm used to seeing that as 19%. Well, we never screw up numbers, right? Because we know numbers have an order. You would probably be very frustrated if I decided from now to the end of the semester, I'm going to just change numbers up. Just this week, it's going to be hundreds, then ones. Well, that's a 1. Wow. 0 for 1. Ones, hundreds, and thousands. That's how I'm going to write my numbers, right? So, okay, so what is what's that? Okay, what's the answer? There we go. Good job. Right? So, hey, it still works out in this case. But what would this one be? This is a good question. If you add 651 plus 800 using our new strategy, we're going to get 461. It hurts, right? It does not work very well. But the problem is with, where am I going with this? You're saying, Mr. JR, you're getting off topic? Yes, a little bit. You need to write the polynomial in the right order because it's okay in math to write x squared plus 2x plus 5. That means the same thing as this, and you'd be like, yeah, I'm okay with that, right? With numbers, you weren't okay with it because it was like, this is hurting my brain to flip things around. But with polynomials, you could write them in any order. It means the same thing. But for our dividing, we want to write biggest to smallest so that we can have our order follow through, just like with numbers. And so this is an important step. All right, let's look at example 1. Then I'll give you some time to try it. Again, so we set it up, we write our polynomial that we're dividing by in the correct order. So this one isn't written in the correct order. So we take some time, start with our x cubed, then our x squared, then our x's, and finally our constant. And we're dividing by x minus 1. Now that we've written it in the correct order, what's our biggest value in our polynomial? It's a 2x cubed. What could I multiply the x minus 1 by to get a 2x cubed? 2x squared. So I'll write that 2x squared over my x squared column and multiply it out. 2x squared times x minus 1 will be 2x cubed, which is what we wanted. 2x squared times the minus 1 will be minus 2x squared. Put that in brackets to subtract. This is 0, which is what we wanted. Every single time here, 3 minus a negative 2 is plus 5 minus 2x plus 5. Yes?
The reason you go like have this like 2 x to the power of 249.
You could keep working your way. You could have as big a polynomial as you wanted. It would just take some more steps, right? Because now we have a new one. Our new biggest value is the 5x squared. The x minus 1 is still there. Now we say, well, what could I multiply x minus 1 to get a 5x squared? 5x. So we write that over your x column and multiply 5x times x minus 1, which gives us 5x squared, and 5x times the minus 1 minus 5x. And we subtract. Sure enough, this is 0. 2x minus a negative 5x is plus 3x. Again, subtracting those negatives is where you're going to make your little mental math errors. So be careful. And plus 5. Now we have a new biggest value. It's a plus 3x. What could you multiply x minus 1 by to get a plus 3x? A plus 3. And there's kind of a hint happening here telling you what you're needing to work with by where your columns are. So when I multiply 3 times the x minus 1, now I have 3x minus 3. 3x minus 3x is 0. 5 minus a negative 3. And for whatever reason, the most mental math errors happen on the very last one. You're so excited about finishing the question. So many people go 5 minus 3 and just write remainder 2 up here so quickly because you feel like you're so close to getting done. And that's where the most amount of mental math errors happen. It's the same thing. But if you wrote a 2 down here, you would lose that. Okay, so there's our answer. And the ones I'm going to get you to try a couple right now are 3A, C, and D, and number 5.